So in this question here, we're going to look at the normal distribution and try to solve some ranges of probability by using what's called the empirical rule. Now, the normal distribution is normally distributed a random variable by mu and sigma squared, where mu is the mean and sigma squared is the variance, the square of the standard deviation. Now, in this particular set of questions here, we've got a random variable y is distributed normally of 51,3 squared. So what that means is that the mean is 51, the standard deviation is 3, and the variance is 9. So using our graph here of the normal distribution with the empirical rule kind of mapped out on it, what we've got is, if we draw a line across the centre there where the mean is, that's the highest point of the probability values. That is going to be where 50% is on this side, 50% is on that side. So for our distribution here, mu is 51. And then it moves across by 1 standard deviation across. Now it will go across technically forever on this side and forever on this side. Now what we've got is this side here is plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations. So our standard deviation is 3, so we can mark them off as certain values. So that would be 54, 57 and 60 and so on. And then the same this way, subtracting 3 each time. So then we go down to 48, 45, 42 and so on. Now technically go on forever and ever, but sometimes these things will find their limit. As for example, if this is, let's say, height of a certain animal, then an animal will have a certain minimum height and a certain maximum height. So technically it does have a limit, but it's not really graphed in this bell curve here, under this bell curve. Now the area under the bell curve always totals 100%, or 1 in terms of a decimal. So with that in mind, we can look at each segment and work out what they are when we're calculating these, because these are set out into the segments. So we've got the segments here either side of the mean, 1 standard deviation either side of the mean is 34.1%. The 2 standard deviations either side are 13.6%. So the last 3 on this side, so 3 standard deviations either side, they are 2.1%. Now these margins here are very, very small, and they're approximately 0.15%. So if I put there 0.15% and 0.15%, just for those little bits there. So they're very, very small. So the probability of that is really, really small. So now we want the probability y is greater than 48, but less than 51. So what I'm going to do is go to the diagram and work out what the value is with the borders of 48 and 51. So 48 to 51 is this one. So that's going to be 34.1%. So 34.1%, that as a decimal is 0.341 approximately. So that would be our probability for this one. Now the next one, y is in between 48, so greater than 48, but less than 54. So again, we go from 48 to 54, and that'd be 2 34.1s. So we've got 34.1% plus 34.1%, which is 68.2%, which is approximately 0.682. So that'd be a probability for that one to happen. Now for y to be less than 48, so for less than 48 we want this side. So we've got a 13.6, a 2.1, and we've got this little margin of 0.15. So if we add all of those up, let's just write that a little clearer. So we've got 13.6, 15.7, and 0.15, that's 15.85%. So then that would be approximately 0.1585 and so on. So that would be our probability for that one. Now for y greater than 48, that would be all this side of it. Now as the probability all adds up to 1, we can just do 1 minus this one if we like. So that would be absolutely fine for that. So 1 minus 0.1585. So that would be 0.8415, or approximately 84.15%. And as you can see, past 48, that has got most of the area under the curve. Then the last one, y is less than 57. So for less than 57, we could add all these up, or we could just do again 1 minus this one and the extent of the n bit there. So then I would do, because we're now written in percentages on this side, 100% minus 2.1% and minus 0.15%. So that'd be minus 2.25%. So then that becomes 97.75%. So 97.75% is 0.9775 approximated. So that would be probability of less than 57. You can see as 57 is here, most of the area is under that part of the curve. So that would be a way of looking at solving normal distribution probabilities by using the empirical rule. Okay.